Hello students, here we will discuss a problem on convective acceleration and total acceleration. So this is the problem, that is finding the convective acceleration at the middle of a pipe which converges uniformly from 0.4 meter diameter to 0.2 meter diameter over 2 meters length. The rate of flow is given as 20 liters per second. If the rate of flow changes uniformly from 20 liters per second to 40 liters per second in 30 seconds, find the total acceleration at the middle of the pipe at 15th second. So here given quantities are diameter at one end of the pipe is 0.4 meters, diameter at the other end is 0.2 meters. So from the figure you can see that at one end we have marked 0.4 meters diameter, at the other end of the pipe we have marked a diameter of 0.2 meters. The total length of the pipe is 2 meters, L is equal to 2 meters. Q, that is the rate of flow or the discharge, is given as 20 liters per second or 0.02 meter cube per second. This is obtained by multiplying 20 with 0.001 as 1 liter is 0.001 meter cube. So Q becomes 0.02 meter cube per second when you convert from liters to meter cube. So there are two parts to the question, that is first one is finding the convective acceleration at the midpoint. Midpoint is marked in the figure as point A, which is at a distance of 1 meters from section 1. Okay. And the second part is that finding the total acceleration at the midpoint A when Q is changing from 20 to 40 in 30 seconds. So the case 1 is to find out the convective acceleration at the midpoint A. So here Q is given as 0.02 meter cube per second and pipe is considered as a one dimensional flow medium. So there is only velocity in x direction. There is no velocity in y and z direction, and also there is no movement in y and z direction. So velocity, you know, has three components in x, y and z directions, that is u, v and w. So here v and w are 0 and velocity has only component, that is u. Convective acceleration is given by the equation u into dou u by dou x, where x is the position coordinate. Since it's a one-dimensional flow, there is only one position coordinate, and u is the component of velocity in x direction. So u multiplied by the derivative of u with respect to x will give you the convective acceleration. Convective acceleration is the acceleration with respect to space. So we have to find out the values of u and dou u by dou x at a distance x from the inlet. Here inlet is considered as section 1. So if we find out the value of u and dou u by dou x at a distance x, we can substitute later any value of x to find out the u and dou u by dou x. So to find out velocity, we use the equation of discharge or rate of flow, that is Q is equal to A into V. That is rate of flow or discharge is given by area of cross section into average velocity. So here to find out u or the velocity component, first we need to find out the area of the pipe, that is the cross sectional area. The cross sectional area of a circular pipe is given by pi d square by 4. So we need the diameter. So here in the problem it is given as the diameter is uniformly changing from 0.4 meter to 0.2 meter over a length of 2 meters. So to find out the diameter of the pipe at section X, first diameter of the pipe at section 1, that is 0.4, minus change in diameter. Change in diameter is 0.4 minus 0.2 divided by length of the pipe, that is 2 meters, multiplied by distance between sections 1 and section X, that is X. This will give you the diameter at section X. That is 0.4 minus 0.1 into X meters. The area of cross section at section X will be by pi d square by 4. Here d is equal to dx, which is the diameter at section X. So pi by 4 into 0.4 minus 0.1 into x, the whole square, is the area of the cross section of the pi at x distance from section 1. Okay, next we have to find out the velocity at the section xx. Okay, velocity is given by discharge or rate of flow divided by area. This is the same equation of rate of flow or discharge, which is given by the product of area and velocity. So velocity is q by a into x, that is area of cross section of pipe at section x, which again is q by pi dx square by 4, that is 4q by pi into 0.4 minus 0.1 into x, the whole square. Okay, finally we get 1.273 q into 0.4 minus 0.1 into x, the whole raised to minus 2 meters per second. So we got u. Now we need dou u by dou x to find out the convective acceleration. For that, we can differentiate u with respect to x. So here we take out the constants, that is 1.273 multiplied by q, and differentiating the term with x, we get minus 2 into 0.4 minus 0.1 into x, the whole raised to minus 3. And minus 0.1x is differentiated to get minus 0.1. So finally it comes to 0.2546 q into 0.4 minus 0.1 into x, the whole raised to minus 3. Okay. So we know that the value of q, that is the discharge, is 0.02 meter cube per second, and x is 1 meters. So we have to substitute that in the equations of u and dou u by dou x. So convective acceleration at the midpoint of the pipe, that is at A, that is x is equal to 1 meters, is given by u into dou u by dou x, which finally comes to 0.053 meters per second square. Okay, now let's move to case 2, which is total acceleration at the 15th second. Okay, again at the midpoint of the pipe. So x is equal to 1 meters and t is equal to 15 seconds. Total acceleration is the sum of convective acceleration and local acceleration. As you have already seen, convective acceleration is the rate of change of velocity with respect to space, and local acceleration is the rate of change of velocity with respect to time. So convective acceleration at the middle of the pipe is given by u into dou u by dou x. Here we already know x, which is 1 meters, but the value of q, which is given in the question, that is 0.02 meter cube per second, has changed after 30 seconds. The new value of q is 40 liters per second. So we have to find out the total acceleration at 15th second with the new value of discharge or q. At time t is equal to 0, we know that q is 0.02 meter cube per second. After 30 seconds, the new q is 40 liters per second or 0.04 meter cube per second. So to find out the total acceleration at 15th second, we need the discharge at time t is equal to 15 seconds. That is obtained by adding the initial value of q with the product of rate of change of q per second and the time 15 seconds. So rate of change of q per second is obtained by finding out the difference between the two discharge values, dividing by the total time. Then the new Q at or new discharge at time t is equal to 15 seconds is 0.02 plus rate of change of Q per second multiplied by 15, that comes to 0.03 meter cube per second. So the velocity is given by substituting the value of Q and X in the equation we found out earlier. So it comes to 0.424 meters per second, and dou U by dou X is also given by substituting the values of Q and X in the equation we obtained in previously in case 1. So that value comes to 0.282. Multiplying U and dou U by dou X, we get the value of convective acceleration, which is 0.119 meters per second square. Okay, so for total acceleration, we need the sum of convective acceleration and local acceleration. So we got convective acceleration. Now we have to find out the local acceleration, which is the change in velocity with respect to time. At t is equal to 15 seconds, the local acceleration is given by dou U by dou t. So we already know the equation of U, which is 1.273 Q into 0.4 minus 0.1 into X, the whole raised to minus 2. Here, you know the value of X, which is 1 meters at the midpoint of the pipe, and Q, that is discharge, is changing with respect to time. So you have to account for that. So the equation comes to 1.273 into 0.4 minus 0.1 into X. Since X is a constant with respect to time t, we take this out of the differential, and then we have dou Q by dou t. So dou Q is a change in discharge, that is the change in discharge at 15th second to initial value. So 0.03 minus 0.02 divided by the change in time. So change in time is 15 minus 0. So the local acceleration value comes to 0.00942 meters per second square. So total acceleration is the sum of convective acceleration and local acceleration. So that comes to 0.02132 meters per second square.